Hello everyone and welcome back to another math video. Today we're going to be looking at how do you graph absolute value functions. So similar to these problems that you see up on the screen here. Just a reminder, this is the normal version of the video. If you'd like the speedrun version where we go through it very, very quickly, I will link that in the description below. All right, your Ricasso Recap starts now. Here's what you have to know before you start this lesson in 30 seconds or less. Firstly, you should know how to graph points. So given a coordinate 2, 3, you should know, okay, one is the x, one is the y, put it on a graph. Secondly, you should know about rise over run, how to calculate it from the line. No, that's the slope. And lastly, you should know how to factor an expression, so greatest common factor. If you don't know these three things, graphing, rise over run, factoring, please do not start this lesson. You need to know those before you start this lesson. I will link refresher videos in the description below. Please go watch those, learn that, and come back to this lesson. All right, new lesson starts now. Here we go. So up on the screen, I have 4 graphs. And what I'd like you to do is I want you to pause the video, and I want you to see if you can figure out the pattern here, okay? How do I know whether it faces up or down? How do I know where the graph starts? Where is the vertex? All right, so go ahead and pause the video, take a look at this, and we will talk about the answer in just a second. Okay, now that you've had time to think about this, let's talk about a few things. All right? Number one is that there's only one graph here where it has been flipped over, okay? And the reason, hopefully, maybe you saw, the reason it's flipped over is because there is a negative sign in front of these symbols are absolute value symbols, okay? So rule number one is that if it's a positive in front of the absolute value, then the graph looks like a V. If it's a negative in front of the absolute symbol, then it is flipped over. Okay, rule number one. Rule number two, the vertex, or where the graph starts, is related to the numbers both inside of the absolute value and outside. All right, and so you'll notice that this number is the same, right? -9, -9. 3, +3. But the number on the inside has changed sign. So it was +1, now it's -1. It was -2, it's now +2. All right? So for an absolute value function, x, we'll say minus a number, plus another number b, all right? This number right here tells you the x-coordinate of the vertex, the x-coordinate. This number right here tells you the y-coordinate of the vertex. And remember that this is reversed, okay, or opposite. Whatever's inside, it's the opposite of what you see. All right, the last thing that we have to talk about is, let's look at this one right here. What happens when there's no number in there? Well, the absolute value of x minus 9 is the same as saying the absolute value of x plus 0 minus 9. All right, and that's how they end up with the vertex coordinate of 0. So if you don't see a number there, there's nothing in the spot, we're going to assume it is a 0. All right, here's our cool clock for today, which means that it is time for you to practice what you just learned. Go ahead and pause the video and try these 2 problems on your own. And when you're ready, you can unpause the video and we'll check your answer. Okay, now that you've had time to work these problems, let's check your solutions. Okay, for the first problem, you should have said the vertex is located at 1, -4. And remember that it is flipped upside down because of the negative in the front. And for the second problem, we should have said the vertex is located at -1, 0, because remember there's an invisible 0 at the end here, and this opens like a V, or shaped like a V. All right, now what happens if we change the number on the outside of the absolute value? So, there's a 1 here, and here is the graph in red. Now what happens if we change that 1 to a 2? Let's take a look, okay? So you can see the graph seems to get a little bit more narrow. And then let's see what happens if we change it to a 3. Okay, and the graph gets even more, we'll say skinny or narrow, right, or crunched in. And so if you want to pause the video and try and figure out what's going on here, I'll give you a second to think. All right, so what we need to notice is that, oh, excuse me. The number in the front is actually related to the slope. So what I mean is, for this one, the slope is 1 because of the 1 in the front. And so you'll notice on the red line, let's get rid of some of these. All right, so for the first graph, we said the slope is 1. And so on the red line, you can see that the slope is 1 over 1, right? We should be familiar with rise over run, which is why, okay, here's where it starts, right? The vertex is 1, 1, and then we go up 1 over 1, up 1 over 1, okay? For the second one, the slope is 2 over 1. So that would be the green or the blue line. So for the blue line, we go up 2 over 1, and here's our blue line, okay? And similarly, this is 3 over 1, so this is up 3 over 1. All right, so the number in the front tells you the slope of your lines. All right, time to practice. Go ahead and pause the video, try these two on your own. When you're ready, unpause, and we'll check your answers. Okay, now that you've had time to work these problems, let's check your solutions. Okay, for the first problem, here is your vertex, 7, 4, and we should have graphed it with a slope of 3 over 1, right? So up 1, 2, 3, up 1, 2, 3, and over 1, and then you can repeat that process. And for the second problem, vertex is 0, 0, and the slope is 4 over 1, and so here is your graph. All right, last thing we have to talk about. What happens when there's numbers on the inside of the absolute value? Well, the answer is there should never be something on the inside of the absolute value, okay? We're always going to move it to the outside. So the way we do that, this is the absolute value of 5x minus 6. You can think of this as the absolute value of 5 times the absolute value of x minus 6. The absolute value of any number is just the positive version, so the absolute value of 5 is just 5, so this becomes 5 absolute value x minus 6. All right, and we should know how to graph this. This is a vertex of 0, -6. It has a slope of 5 over 1, and here is the graph. Now for the second problem, a little bit trickier. We have, I'm right at the bottom here, the absolute value -2x plus 6 minus 7. So here you have to factor out of both, right? And I said at the beginning of the video you should know how to factor. So this is like saying the absolute value of -2, actually let's write it like this first, times, and this becomes x minus 3 because you factored out a -2. And now this is like saying the absolute value of -2 times the absolute value of x minus 3 minus 7. And lastly, the absolute value of -2 is just 2, so this becomes 2 times the absolute value of x minus 3 minus 7. And we should know how to graph that. So we say the vertex is 3, -7, 3, -7. And it's got a slope of 2 over 1, so 2 over 1, 2 over 1, and here's the graph. All right, time to practice. Go ahead and pause the video, try these on your own. When you're ready, unpause, and we'll check your answers. Okay, now that you've had time to work these problems, let's check your solutions. Okay, for the first problem, should have factored out a 3 and then said, okay, the vertex is -5, 0, and then we do, slope of 3 over 1. And for the second problem, you should have said the vertex is 0, -5, and it has a slope of 6 over 1, so here's your graph. All right, that is it for today. I hope you all have a good morning, good afternoon, good evening, and good night.